Hello, this is Shakib Gaji, and today we'll be starting a new chapter named Geometrical Optics. And we will not be studying line by line or everything that's given in our book. That's for that you just read the book and you will understand everything. However, I will try to make the chapter very small, gist of the chapter, which will be used for doing maths. I'll discuss about the topics or the concepts that will be required for doing the maths. Okay, so let's start. So at first, the main or the most important formula of this chapter, so I will say the only formula of this chapter is the Snell's law. See, if we have a medium, suppose this is the medium and this is the denser medium and this is the light medium. If it is the perpendicular we draw, and if a light enters from this medium, the light will bend towards the normal to this plane. We all know these things, right? So suppose the light is coming from medium A to medium B. So if we write A nu B, we can write refractive index of medium B by refractive index of medium A with respect to vacuum. We also can write speed of light in medium A by speed of light in medium B, or we can also write the wavelength of light in medium A, the wavelength of light in medium B is equals to sine I by sine R. We all know the Snell's law. I don't have to tell you. We have to use these relations to do our maths. From Snell's law we get, if a light enters into B medium from A medium, then the refractive index of B medium with respect to vacuum divided by the refractive index of A medium with respect to vacuum is equals to speed of light in A medium by speed of light in B medium is equals to wavelength of light in A medium divided by wavelength of light in B medium is equals to sine I. I means incident angle and R is refractive angle. Means this angle is the I or the incident angle, the ray that's coming from medium A, the angle that is made with the normal divided by sine of the angle of the refracted ray created with the normal to this plane. So using this formula we can do several maths, and actually in this chapter most of the maths you will see are based on these formulas. See, primarily when we are discussing about geometrical optics, we deal with reflection and diffraction. However, in these chapters, most of the problems that we'll be facing will be based on the refraction, not reflection. So whether the object or whether the optics exhibits reflectional properties or refractional properties doesn't matter. There will be two types of images that will be created in this optics. One is virtual object and another is real image. Sorry, not object. One is virtual image and another is real image. So when the image that is created is real, we use positive sign, and when the image that has been created is virtual, we use negative sign. Now please, if you are have to give you a reminder, if we even don't understand, like construction wise or drawing wise, how real image is created, how virtual image is created, see, it's better that I don't teach you what's real or virtual image. You make yourself learn by yourself. You can search on YouTube, you can see the books, there are thousands of videos, so there are very precise what I can say, knowledge given already in the book. You can just read it out. However, those are very preliminary discussions. Let's just stick with maths. Okay, so if real image, we'll be using the plus sign, and virtual image, we'll be using the negative sign. Again, real image in terms of refraction, real image is formed in convex lens and virtual image is formed in concave lens. However, we sometimes in our question paper we see that a lens, the given lens is convexo concave. In this case, whether we will consider plus or minus is actually based on the last name that has been given. If it is convex or concave, so concave. For concave we have negative sign for virtual, means it will exhibit the virtual image property. The last name will exhibit the type of lens. So what type of sign, positive or negative, will be used. Okay, now see, though I should not be talking about this thing, but let's just give a brief elaboration. I say, suppose we know if here is one convex lens and this is the focal point and this is the focus, let's say this is the radius of the curvature. If an object is placed at an infinite distance, suppose at an infinite distance, that is u is equals to infinity, u means the position of the object, the distance of the object, then the image that will be formed will go through, then the image will be real, very diminished. Again, if the object is between, again, if the object is just after the r, we all know, right, r is equals to 2 of f. So if the object is at a distance not infinity but greater than r, suppose here, so u is greater than 2f or r, then the object will be real and diminished. Again, if the object is at r, then it will be real and the size of the object, suppose the size of the object is h, then the image size will also be h, means the size remains unchanged. Now if u is less than 2f but u is greater than f, means if the object is between r and f, then it will be real and magnified. If u is at the focal point, then the object will be real and very magnified. If the object is situated after the focal point, that is u is less than f, then the object is virtual and magnified. Now one more thing, a real image is always inverted. However, a virtual image is always erect. So we can say in convex lens, other than the possibility that the object is after the focal point, the image will always be inverted. Only if the object is after the focus or focal point, the image will be erect. Okay, so we have given the problems and I don't know whether you can see because the ink of this pen has finished and I don't have a marker right now. See, it's given that the refractive index of water with respect to air is 1.33. We can write the same equations as Snell's law. As new refractive index of water by refractive index of air is equals to 1.33. Refractive index of water with respect to glycerin is equals to 0.905, and the same things we can write as nu W, that is refractive index of water by refractive index of glycerin is equals to 0.905. In the same way, refractive index of glycerin with respect to glass is equal to 0.9524, that is nu glycerin by nu G is equals to 0.9524. This is 4. Now see, we have to find the refractive index of glass with respect to air. That is nu G by nu A. So nu G by nu A can be written, see, now we have to adjust these three equations that eventually will convert into this equation. So nu G means the refractive index. So nu G means the refractive index of glass will be at the top. See, in all this equation, the refractive index of glass is at the denominator side, but here the refractive index of the glass is at the numerator side. So if we inverse these equations, means if we write nu G by nu GL, then we are getting the refractive index of glass on the numerator side as given in here. Now we have to cut this refractive index of glycerin, because in the denominator side we have refractive index of air. So to cut this refractive index of glycerin, we have to multiply with the fraction that will have refractive of glycerin on the numerator side. So see, in this equation we have refractive index of glycerin on the denominator side. So if we put the inverse of these equations, we'll get the refractive index of glycerin on the top. So nu GL by nu W. So this and this will be cut. However, we are getting at the denominator the refractive index of water, but in our main problem, in the denominator we have refractive index of air. So again we have to multiply, or we have to cut this refractive index of water from the denominator. For this we can see this equation. If we have nu W, refractive index of water, by nu A, refractive index of air, now see, with this equation, this refractive index of glycerin can be cutted out with this refractive index of glycerin. Again, this refractive index of water can be eliminated by this refractive index of water. The denominator and numerator will be cutted out, and in this case also the numerator and denominator will be eliminated. Eventually it remains in the numerator side the refractive index of glass, and the denominator side the refractive index of air, as per our required fraction. So nu G by nu GL, we just have to inverse this. So 0.9524 inverse into nu GL by nu W by nu GL. So we have to inverse this as well. 0.905 inverse into, see, we don't have to do anything with this, nu W by nu A, 1.33. So the answer you will get will be the refractive index of glass with respect of air. I hope I have been capable to understand it. Just think it's a very easy math. You just have to adjust the equation to make the eventual outcome like this.